Hello everyone, welcome to Focal Point. Now we are going to take another standard example, and this is a good example to understand our structure in a better way. So some more thing we are introducing in this example. So this is a simple definition of of a structure. We have given the name S1 in here, and we have defined integer a, float b, and character c. So this is semicolon is important, and this is the definition of it. So right now this this is just a definition. No size will be allocated right now, but what is the size of this integer? 2 byte, float 4 byte, in character 1 byte. So the size of this structure should be 4, 6 and 7 byte. So size of this structure will be 7 byte, but right now that 7 byte will not be allocated. But when we will be initializing the value and defining a variable, and at that time our size will be allocated. Right now this is just a definition, and so no size will be allocated. And another structure we are going to define it in here, and what is the name of it? We have given the name s2, and we have defined a character variable and a structure of type s1, and given the name e and a float value. And this is really very good thing to know. This is a very important thing to be note down. We cannot define the same structure itself inside the structure. I mean, we are defining our structure s1, so inside this we cannot define s1 again, because the size of it is not known, or we can say we have not given the definition of it. So if you want to define, I mean, in this case we are defining our structure in here, because we have already given the complete definition of it. Okay, and that's why we can use this. So the same definition cannot be given inside the structure of same type. Okay, so here we can define the s1, but we cannot define the s2 itself, because we are giving the definition right now. So at this time we are not allowed to do so. But if you want to just define the pointer to the same data structure, same structure type. Okay, so we cannot define the structure itself, but we can define the pointer to the same structure. Okay, that means if you want to define s2, so we cannot do like this, but if we want to do, then we can define the pointer to this structure. I want to say that this is correct, but this is not correct. Okay, so we need to keep in mind. So I want to change this to our previous code, and this is our two definition, and this is the simple definition of the structure, and here we are giving a structure inside the structure. Okay, so, and this is absolutely correct, and we are going to initialize our s2 in here. So we have given the variable of type structure s2, and we are going to initialize our data type. So what will be the size of it? This is 7 byte, this is 1 byte, and this is 4 byte. Okay, so this should be the of size 12 bytes. 12 byte will be allocated in here in a real sense. So actually the size will be allocated, 12 byte of size will be allocated in here, and no size will be allocated during the definition. And this is our initialization. We have initialized our d, and we have initialized our three values: integer, float, and character. Integer, float, and character, and after that this float. So this is how we are going to define. So if we have to initialize our structure inside a structure, then we have to use this parenthesis. And now we are going to print our values. So what we are going to do in here, we have used our select operator 2 times. Why? Because we have used our nested structure definition. So if you want to access our b, through this structure, then we have given g dot e dot, because inside g we have e. Okay, and inside e we want to access b. Okay, and that's why we have given like this. So g dot e dot b, then what will be printed in here? It will be printing this float value 20 should be printed. And now we are going to print g dot f. So what will be printed in here? Inside g, inside just g, we are going to access this float value, and that's why 30 should be the output of it. So here 20.5 will be printed, and here 30.5 will be printed, and here we are going to print the address of our structure g. Okay, and at this stage we are taking a pointer of type structure s2, and we are going to give the address of our g. So no problem here. And so we h contains the pointer to our structure g. Okay, now we can also access the value using our pointers. So what we are going to do, we have we can write something like this. So what is the meaning? The exact meaning of this is, this has the exact meaning like this. So asterisk h mean we are accessing g value, and after that we are writing e dot b. So our answer will be this 20.5. okay, because inside g we are going to access e, and inside e we are going to access our variable b. So b's value is 20.5. okay, and now one more important thing. Now if we don't want to give this expression, or we can also give that this expression like this also. That means this is little complex. That means we are accessing the value that is pointed by h, and after that we are accessing the value inside this. So in the place of that we can also simply use h and this operator, and this is minus and greater than operator. So this operator says has the same meaning like in here. That means it will access the value of um, uh, pointed by h, and it will access e. okay, so this is the meaning of it, and after that we have simply done dot b. okay, so we can write this line like this. okay, so this is also important thing, and this is really being used because this is actually simple to execute, because when we are working on pointers then we can write this. This is quite simple and feasible to use. So what will be the output of it? So output will be same 20.5. so let's see what is the complete output of it. I've told you that the output of this should be 20.5, output of this should be 30.5, and here address of g will be printed. In here the output will be same as in here 20.5, because we are accessing this value using our pointer, and we can also replace this line by this, and the same 20.5 will be printed in here. So let's save the code and try to compile and run it. So let's see our output matches or not. And yeah, the first is 20.5, second is 30.5, then address of our g variable, and after that 20.5, 20.5. so this is a very important thing that we need to know. So you can also try this code by your own and see what is the output of it. Thank you so much. See you in the next video.